Today we're going to take a look at rational and square root equations from Unit 10. We're going to take a look at how to solve rational equations, some that are a little bit simple and then others that are a little bit more complex. We're also going to look at extraneous solutions, which means solutions that where we get a solution, it seems like it's the answer, but then when we plug back in, we don't actually get an answer because it doesn't make a true statement. We're going to learn about inverses of functions as well, how to find function inverses. And we're also going to be solving square root equations and looking at those extraneous solutions. So our first problem we're going to look at is just a quick introduction to rational equations. And we're going to solve for a variable given an equation. So it says solve for k, and we have 4k minus 10 over k equals 8. And so the first thing that I would do here is just multiply by k on both sides. And I'm just writing over here to save a little bit of room. But when we do that, that k cancels out with that k. And now we're left with, I'm going to write my answer up here, 4k minus 10 equals 8k. And this is a simpler equation. And if you're good with algebra, you probably know how to do this quite well. Just minus 4k on both sides. You get negative 10 is 4k. We're going to divide by 4 on both sides. And we get k equals negative 10 over 4, which equals negative 5 over 2. So that's our first solution there. Okay, so that one wasn't too bad. Same thing for this next one. We're just going to multiply by 2k on both sides. Cross out the denominator. We get 3 equals 10k. Divide by 10 on both sides. And we get k is 3 over 10. Pretty simple. We'll do one more of these. Solve for n. Going to multiply by 2n. And multiply by 2n. And it gives us 4n minus 2 equals 14n. And I'm solving these fairly quickly because this is just some basic algebra review, I think. And that's going to give us 10n. Divide by 10. We get n equals negative 2 over 10, which equals negative 1/5. Okay, so those are the intro or the easier questions for rational equations. Let's look at some tougher ones now. So now we've got a lot more variables to deal with in this next one. It says find all the solutions in the equation. And so in order to solve this, we've got to apply a few things that we've learned so far in this course. And one of them is factoring. Another one is factors or factor groups. Um, and the easiest way to solve these, there's two different ways you can solve them. So one way is you can solve by cross multiplication like this. That definitely works, but I like to match up the denominators and get rid of the denominators. And what I mean by that is let's find a common denominator. Here we have x times quantity x minus 2, and here is just x minus 2. Very easy. We just have to just times by x here to make that denominator the same. Now, if I times by x on the bottom, got to also times by x on the top of that fraction. So we've got, just a second here. We've got x squared plus 20 equals x times 14 minus x over x minus 2, like that. So now we have the same denominator, and this simplifies our equation tremendously. When we have the same denominator, we can just get rid of the denominator. And the reason is, if we multiply this side by x times quantity x minus 2, and we multiply That means we have to multiply the other side by x times quantity x minus 2. That's going to cross that out. That's going to cross that out. So now our denominators are completely gone. And all we have to worry about now is just solving this equation. So now we get x squared plus 20 equals x times 14 minus x. And we're just going to use the distributive property on the right side. Left side stays the same. And again, this should probably be a review for you if you've done this recently. That's great. I'm just going to set this equal to 0 now. And we have 2x squared plus 20 equals 14x. I'm going to subtract 14x on both sides. And we get 2x squared minus 14x plus 20 equals 0. So there's where we are so far with getting a quadratic now out of this. Now we can factor out a 2 and we can do the AC method in order to factor this. If you didn't factor out a 2, it would be a times c is 40. And then all the ways to get 40, which adds up to negative 14. Actually, let's just factor out the 2. That's standard to do that. So do x squared minus 7x plus 10 equals 0. So now a times c is a little bit easier. A times c is equal to 10. 1 times 10 is 10. And we have to figure out, well, what do we multiply together to get 10 that adds up to equal negative 7? And this should be a review with using the standard AC factoring method. So the numbers we need here is negative 5 times negative 2. So now we're going to rewrite this as 2 times, and I'm just going to put brackets here. This 2 ends up just getting divided out anyway. It's really not that important. But now it's going to be x squared minus 5x minus 2x plus 10. And then we would put the brackets there. And then we're going to separate these. And again, this should be a review with the AC method. We're going to separate those, and it looks like we've got to our next problem there. So I'm going to just kind of go to the side here. So now this is 2, and this is x. We're going to factor out an x, and we're left with x minus 5. We also have to write x minus 5 over here and figure out what number goes out here. If we multiply it, it's going to equal all this stuff. And that's just minus 2. So when we factor this, we end up getting 2 on the outside, x minus 2, it's these two numbers here, x minus 5. So our solutions are now, we set these equal to 0, and this is all equal to 0. So you could divide this 2 and still get the same thing. So the 2 goes away pretty much, but that's less important. So we're setting this equal to 0. So x minus 2 equals 0, and x minus 5 equals 0. So we get x equals 2 and x equals 5. So that's what our solutions are. But before we say that, we have to check for extraneous solutions. An extraneous solution means we got the solution, but it's not actually an answer. So we have to plug back our answers into the original equation and see if it makes a true statement. Now, because this x squared plus 20 equals x times quantity 14 minus x, because we were able to do all that, we can actually just plug in our answers to this. But if you really want to, you can plug it into the absolute original. I'm going to plug it into this and see if we get a true statement. So we're going to start with x equals 2. So we're going to do 2x squared over here, 2 squared plus 20 equals 2 times quantity 14 minus 2. we get 4 plus 20 equals 2 times 12. That's 24 equals 24. And that's a true statement. Okay, so actually, we got to back up here because even though that's a true statement, we do have to use the denominators for this. I apologize. We're going to go back and look at the entire equation now. So I'm going to erase this. So that's how we would check it if it was just a standard equation. But here we're looking at everything on the denominator. If we plug in 2 for x, we get 0 on the denominator. That's not allowed. We cannot have a 0 on the denominator. That's undefined. So therefore, our x equals 2, x cannot equal 2. If we plug in the 2 there, we get 0. If we plug in the 2 here, we get 2 times 0, which is 0. So that does not work. But if we plug in 5, that should be okay. Let's check it with the entire equation. I was trying to find us a shortcut before, and we just can't do that with rational equations because we have to plug in the number in the denominator to check to see if it makes the denominator ever equal 0. So we'll try 5 squared plus 20 over 5 times 5 minus 2 equals 14 minus 5 over 5 minus 2. So far, so good. We don't have a 0 on the denominator, so that's a good sign. 25 plus 20 over 5 times 3 equals 14 minus 5 gives us 9 over 3. So this becomes 45 over 15 equals 9 over 3. 3 equals 3, and that's a true statement. Earlier, when I checked to see if we had a true statement, I was checking just the top here to see if it made it true. And 2 does make just the top true. But if we include the denominator, then we get an extraneous solution. So the only solution for this says choose all that apply. The only solution for this is 5. All right. We'll do one more example with these. And I think what we'll do is we'll skip example 3 because that's kind of a lot of examples to go through. So we'll do this one more. So take a look at the denominator, and we're going to try to figure out what do we need to multiply the denominator by so that we have a common denominator. In this case, we're going to multiply by x plus 2 and x plus 2 on the top. So now we've got a new equation. X plus 2 over x plus 2 is just 1. That's why we're allowed to do that. So now we have a new equation. If we multiply by the denominator on the right and the left, our denominator cancels out. And we're left with this nice equation just on the top. We do have to go back and check for extraneous solutions at the end. But for now, we have a nice equation on the top. We're going to use the FOIL method and multiply the top. And that's going to give us x squared minus 3x plus 2x minus 6 equals 4x minus 6. Combine like terms. Set equal to 0. Still setting this equal to 0 by adding the 6 to both sides. And now we should have equals 0 like that, as that just cancels out there and there. Now here we can just factor out an x, and we're left with x minus 5. So our solutions are x equals 0 and x minus 5 equals 0. We add 5 to both sides and we get x equals 5. Now, so far we have those two answers, but we have to check for extraneous solutions. So if we plug in both of these, we should get an answer that doesn't give us 0 on the denominator, but we can check all the rest of this. So if we check for 0, this was the last problem. I'm going to erase some of this so it doesn't get too confusing as we're solving this here. So if we plug in x equals 0, we would get 0 minus 3 over 0 plus 1 equals 4 times 0 minus 6 over 0 plus 1, 0 plus 2. We get negative 3 over 1 equals negative 6 over, and that's 1 times 2 is 2. And that's negative 3 equals negative 3. So 0 is a solution. Uh, we checked that because we used the entire equation. We used all of it. And we can plug in 0 and not get 0 on the denominator for either of these. If you type in anything divided by 0 in your calculator, you'll get an undefined answer. It'll say error or undefined. Now let's plug in 5. 5 minus 3 over 5 plus 1 equals 4 times 5 minus 6 over 5 plus 1, quantity 5 plus 1 times quantity 5 plus 2. Gives us 2 over 6 equals 20 minus 6 over 6 times 7 is 42. 2 over 6 equals 14 over 42. And if we divide by 7 over 7, 2 over 6 equals 2 over 6. And that's a true statement also. So x also equals 5. All right, so it's very important to check for extraneous solutions with rational equations. Usually you can just plug in the denominator and see if it gives you 0 or not. We're going to skip example 3. It's just the same basic steps as before. Now we're going to go to inverse functions, inverses of rational functions. So the inverse is a really simple way to solve for the inverse is just to switch the y and the x values, and that will give you the inverse function. So if you switch the y and the x values, if we treat h of x as y, so if we just say h of x is equal to y, we can rewrite this as y equals all of this over here on the right side. Now I'm just going to write x equals all of this. 3 minus y. So we're switching x's and y's. And now we're going to solve for what our new y value is. Our new y value is the inverse of h of x. So we're going to just do times y plus 1 on both sides. And we get x times quantity y plus 1 equals 3 minus y. And the goal is for all these is to get the y's on the same side and then factor out a y. So we're going to multiply. You get xy plus x equals 3 minus y. We're going to add y and add y. We get xy plus x equals 3. Subtract x. We get xy plus y equals 3 minus x. Now we're going to factor out a y. We get x plus 1. Because when we take out a y, 1 times y is y. And of course, x times y is y times x. So we just factored out greatest common factor is y. I think this is probably the toughest part of all the steps is doing that. So now this is 3 minus x. And then we're going to divide by x plus 1 on both sides. And we get y equals 3 minus x over x plus 1. And we would say, you can add this if you want to, where x is not equal to negative 1. Because when we set x plus 1 equal to 0, then we get x is negative 1. But when we plug in -1 for x, we get 0 on the denominator. So you can write that. That's not really part of the problem. But our final solution is the inverse of the original is 3 minus x over x plus 1. So that's how to find the inverse. Swap the x's and y's and solve for what the new y value is. Okay, I'm going to take a look and see if there's, so we've got 3 examples planned, but we'll just do 2 because they are kind of repetitive. They're kind of the same thing. So let's look at the next one. We're going to do the same thing, swap the x's and y's. We're going to write this as x equals -2y minus 1 over y plus 5. I'm going to multiply by y plus 5 on both sides. And if you want to know more about inverses, I would very much suggest looking at graphing inverses as well. That way you can understand what it is graphically. But we're not gonna really go into detail with that today. Okay, we're gonna multiply this. So this is xy plus 5x equals -2y minus 1. We're gonna get the y's on the same side. We're gonna get xy plus 2y plus 5x equals -1. Subtract by 5x on both sides. And now we have xy plus 2y equals -5x minus 1. Okay, and then we're going to factor out the y. And we're left with x plus 2 equals -5x minus 1. And then we're just going to divide by x plus 2 on both sides. Those cancel there. Same thing as the last one, pretty much. This 1 and x plus 2. And that's what our inverse is. Inverse of h of x is equal to that. Okay. All right. So if we were to plot these, actually, let's just do that. Let's take a look at Desmos on here, just very, very quickly. We'll take a look at what this is going to look like if we plot it. So I'm going to write y equals -2x minus 1 over x plus 5 as one equation on Desmos. And I'm just writing that right now, and then I'll share my screen with you in just a second here. And then we're going to write what the inverse would be. And so then the inverse, we're going to write on a different line, y equals the answer for our inverse. And we'll take a look at what these graphs look like graphically, just so we can get a general sense of what's going on here. Okay. So here's what the inverses are. So let me see if I can find a couple points on here. Here's what the inverse looks like of the graph. So this one's a little bit challenging to see because it's a rational function graph, but this is what it would look like on the graph graphically. Let me share a different screen with you here. Oh, let's see. So here's our original, and then here's our inverse function. So an inverse function, it gets reflected, and it gets reflected over the line y equals x. So this is kind of a trickier example to look at with inverses because it's a rational function, but that's what the inverse would look like if we graphed it. All right, let's take a look at the next section here. We're going to skip the next inverse function and go to square root equations. So for square root equations, we want to square both sides to get rid of the square root. And we also have to check for extraneous solutions with square root equations. And we'll get into that after we do all the details of finding our final answer for W. In fact, we're going to have to use the quadratic method for this one, and that's going to take us a little bit of time. So the first thing we're going to do is we're going to square both sides. When we square a square root, it makes the square root go away. Now we're left with 3w minus 7 quantity squared equals 8w minus 7. Okay, and what happens is we are going to rewrite this way, like that. And we're going to do the FOIL method. We get 9w squared minus 21w minus 21w plus 49 equals all of this over here. So we get 9w squared minus 42w plus 49 equals 8w minus 7. Okay, and we're going to do the same thing. We're going to set this equal to 0. So we're just going to minus 8w on both sides and plus 7 on both sides. And I'm doing two operations at once, but that's just basic algebra here. So now this is going to be minus 50w plus 56 is equal to 0. Now we can try and factor out the greatest common factor from this. In fact, I would suggest doing that just to make it a little less complex, but there really isn't a greatest common factor here. We could try to factor out a 9, but that doesn't really work with the 50. So this is not going to go well for us with factoring. We're going to have to use the quadratic formula. The quadratic formula is minus b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. And remember, our quadratics are in the form y equals ax squared plus bx plus c. So we're going to plug in these values. I like to write my values on the side, even though they're right there. I just feel like that's helpful for me, just so I don't miss a negative on accident. So b is negative 50 in this case. So minus negative 50 is positive 50, plus or minus square root of negative 50 squared minus 4 times 9 times 56, all divided by 2 times 9. We get 50 plus or minus the square root of, these numbers get a little bit tricky to calculate. I'd suggest using a calculator if you need to. And then this is minus 4 times 9 times 56 is 2016, all divided by 18. Okay, now we get 50 plus or minus, because when we do square root, it's the positive or the negative value, because two negatives multiplied together can give us a positive. So that's why we do plus or minus. And we get 484. Divide that by 18. The square root of 484 is a nice even or a nice integer number. It's 22. 50 plus or minus 22 over 18. So this gives us, I like to write my answers like this. This gives us 50 plus 22 over 18 and 50 minus 22 over 18. So that's 72 over 18 and 50, excuse me, 28 over 18. And this is for W. Saying this is what W is from our original equation. Normally we solve for x, and that's our x-intercept, but this is what W is equal to, and we have to simplify this. This ends up being W equals 4, and our other value for W is W equals 14 over 9. Okay, now I think I said it in the beginning, we have to check for extraneous solutions. So we're going to go back up to our original problem. Get rid of all that. We're going to plug in 4 for W first, see if it's a true statement. Then we're going to do the same thing for 14 over 9. So if we plug in 4, say when W equals 4, we get 3 times 4 minus 7 equals the square root of 8 times 4 minus 7. And we get 12 minus 7 equals square root of 32 minus 7. That's 5 equals the square root of 25. And we get 5 equals 5. So that's a true statement. So W equals 4 is a true statement. And we can just write 4 there. Now, it's not always a good idea to assume that that's extraneous. So let's check it just to make sure that it is, because it could maybe be a solution. So we'll do the same thing for 14 over 9. So when W equals 14 over 9, we get 3 times 14 over 9 minus 7 equals the square root of 8 times 14 over 9 minus 7. And this gets a little tedious, I think, with common denominators and everything. We can do that, but let's for now we'll just say this is probably an extraneous solution. So I would type 14 over 9 in your calculator. We get a decimal of 1.5 repeating minus 7 and then times by 3. And the decimal is negative 16.3 repeating. And we want to know if that equals the square root of this. So we'll do 8 times, we'll do 14 over 9 first, times 8, and then minus 7. And that gives us 5.44. Well, we already know we have a negative here, and we can't get a negative when we do the square root. And this is 5.44. And just to simplify it further, if we did continue it, it would be it's about this. 16.3, negative 16.33 is equal to 2.33. That's not true. So that's an extraneous solution. All right. Let's see if we can do one more of these. This one's a little less time consuming. It says solve for y. We're going to do the same thing. We're going to square both sides. And that makes the square root go away on the left side. We have 2/3 y minus 7 equals 81. This one's a lot more simple. We're going to plus 7 and plus 7. You get 2/3 y equals 88. We can times by 3 over 2. That's multiplying times the reciprocal to save you a step. Or you can do times 3 and then you can divide by 2 if you want to. But that'll cross that out. So we just get y on the left. 3 times 88 is 264 over 2, and we get y equals 132. Now we have to check for extraneous solutions just to make sure. So we're going to plug that back in to the original. 2/3 times 132 minus 7. Make sure that 7 goes under the square root is equal to 9. We're plugging it into the original, not what I did with the squaring. So just be careful of that. I almost wrote 9 squared there, and that wouldn't have been correct. So when we check that, we get 2/3 times 132 is 88 minus 7 equals 9. Square root of 81 equals 9, and that is a true statement. 9 equals 9. So y does in fact equal 132. All right. So we took a look at just an introduction to square root equations. Let's look at some tougher ones next. So this one says choose all that apply. We'll solve one of these with the, let me see here. Let's see, I think we're going to solve them with the quadratic formula again. So we'll look at one more like that, and then I'll show you a shortcut method for the second example that I think can save you a little bit of time for these. And the shortcut method is good whenever you have multiple choice, but we'll go over that in just a second. So for square root equations, um, we want to isolate the radical. Because we're going to square both sides, if we just took everything here and squared it and everything here and squared it, that's going to give us something a little more complex than if we just had the square root by itself. So to start with, let's add all of this to both sides. And that's going to give us 5w on the left equals the 3w plus minus 1, and then plus our square root of 27w plus 7. Now we're going to subtract 3w and add 1 to both sides. So that's going to give us 2w plus 1 equals the square root of 27w plus 7. Okay, now we're going to square both sides just like we did from before. And this side is just going to be 27w plus 7. And I like to write out the quantity squared because sometimes I forget. Sometimes students will solve this incorrectly as well. This is not the same as 2w and then squaring it and then 1 squared. You can't just bring the squared over to both of them. So that's why I like to write them out like this. You don't have to if it makes sense to you on how to multiply this out. If you're really good with figuring out the FOIL method, you don't have to write it out like that. I just do it out of habit. So that's 4w squared plus 2w plus 2w plus 1 equals 27w plus 7. 4w squared plus 4w plus 1 equals 27w plus 7 minus 27w because our goal is to set this equal to 0. And we're also going to minus 7 on both sides. So now we have 4w squared. 4w minus 27w is negative 23w. 1 minus 7 is negative 6. Those cancel out, and now everything's equal to 0. Now, when we do AC method, we might be able to do AC method with this instead of quadratic formula. Let's try it and see if we can. So 4 times negative 6, A times C, is negative 24. And negative 24 times 1 equals negative 24. And if we add them together, we get negative 23. So here we luck out. We can use the AC method instead of the quadratic formula. So this now becomes 4w squared minus 24w plus 1w minus 6 equals 0. We're going to factor by grouping. Find the greatest common factor. It's 4w, and that leaves us with w minus 6. This w minus 6 matches up great with that, so that means we're on the right track, and we just have to put a 1 out there. So this equals 4w plus 1, and w minus 6 equals 0. Set these equal to 0 individually. And we get w equals 6, and 4w equals negative 1. Divide by 4 on both sides. We get w equals negative 1/4. Okay, so those are our answers that we get for w, negative 1/4 and 6. Now we have a square root problem. We have to check for extraneous solutions. And this, I think, this might be giving us an example of a negative. A lot of times when we're finding extraneous solutions with a square root, we find out that we end up getting a negative underneath the radical. So when you have a negative under the radical, like if you had the square root of negative 1, that's going to give you an error in your calculator. In fact, that equals the imaginary number I, because it's not able to be computed. The reason is, if we take the square root of a negative, any two negatives of the same number is going to give us a positive. So it's impossible to have a negative underneath the square root. Okay, so we're going to plug in negative 1/4 for w and 6 for w. So to do that, We're just going to use our original equation. So let's go back up here. Let's start with negative 1/4. That one's a little tougher, so we'll start with that one, I guess. So 5 times negative 1/4 minus the square root of 27 times negative 1/4 plus 7, all under the square root. That's really important. If it's all under there, you keep it under the square root. If it's separate, you keep it separate. Okay, so now this is negative 5/4 minus the square root of negative 27 over 4 plus 7. I'm going to times this 7 by 4 over 4 so that later we can add it together all nicely with the common denominator. So now this is negative 3 times negative 1/4 is negative 3/4. And that was, I couldn't read my own writing there for a second. That's minus 1. And we're also going to times that by 4 over 4 so we can combine these. So now let's rewrite this. We have negative 5 over 4 minus the square root of negative 27 over 4 plus 28 over 4 equals negative 3 over 4 minus 4 over 4. Negative 5 over 4 minus the square root of, that's just 1/4. That's a nice number. Let's fix our square root, save us some room. And that's going to be negative 7 over 4. Now, when we do the square root of 1/4, we're doing a minus on the outside, so we're allowed to do that. And that becomes square root of 1 over square root of 4 equals negative 7 over 4. Square root of 1 is just 1. Square root of 4 is 2. And we want common denominator again, so we're going to times by 2 over 2. We get negative 5 over 4 minus 2/4 equals negative 7 over 4. We get negative 7 over 4 equals negative 7 over 4. Okay, so that's W equals 1/4. That solution checks out. So negative 1/4, A, is one of our answers. Now we got to check W equals 6. So we're going to do the same thing, but plug in 6 for W. And we're using our original equation again. Don't do any shortcuts like I tried to do on our first rational equations problem. Just use the original equation. And if you've made any notations, make sure to erase those just so you don't get confused. So now this is 5 times 6 minus the square root of 27 times 6 plus 7 equals 3 times 5 minus 1. Excuse me, 3 times 6 minus 1. Plugging in 6 when W equals 6, not when W equals 5. Okay, so now this is 30 minus the square root of 27 times 6 is 162 plus 7 equals 18 minus 1. 30 minus square root of 169 is equal to 17. 30 minus 13 equals 17. And we get 17 equals 17. And that's a true statement also. So W also equals 6. Okay, but we still had to check for those extraneous solutions. All right, so this next method might save you time, it might not. This is a common strategy on the SAT and other tests to save you time. And that is looking at the answers and picking the value and seeing if it works. So it says choose all that apply. And y is our variable. So for A, we're going to check when y equals 7. Or negative 7, excuse me. And we're going to plug that in, see if it makes a true statement. So this might save you time. But for some people, they might disagree and say, I like the first method. I like to just know what the answer is and and figure it out instead of plugging in answer choices. You can do that too if you need to. So negative 4 equals 2 minus square root. Whenever we square negative, that's negative times negative, which gives us positive. Plus 28 plus 15. Negative 4 equals 2 minus the square root of 92. Negative 4 equals 2 minus, this is about 9.5916. And that's not true. So y does not equal negative 7. I'm going to cross it out like that. We'll put checks by the ones that it is. Okay, then we'll check B. Keep going here. For B is when y equals negative 3. Negative 4 equals 2 minus the square root of negative 3 squared plus, excuse me, minus 4 times negative 3 plus 15. Negative 4 equals 2 minus square root of 9 plus 12 plus 15. We get negative 4 equals 2 minus square root of 36. Square root of 36 is 6. And we get negative 4 equals negative 4. That one checks out. So negative 3 is an answer. And all we're doing here is we're checking for extraneous solutions. We're just kind of pretending that these are all solutions that maybe were found and then checking to see if it's extraneous or not. So we'll check C and D next. So for C, it's when y equals 3. Negative 4 equals 2 minus square root of 3 squared minus 4 times 3 plus 15. Negative 4 equals 2 minus the square root of 9 minus 12 plus 15. Negative 4 equals 2 minus the square root of, that's just, let's see, it'd be 12. Negative 4 equals 2 minus about 3.4641. And that's not equal. That would be about negative 1.4 or something. So not C either, not 3. We can cross out E. It says the equation has no solutions. Well, we found one solution, so we can cross that out. So now we just have to check D. So for D is when y equals 7. We did negative 7 earlier. Negative 4 equals 2 minus square root of 7 squared minus 4 times 7 plus 15, all under the square root. And that's 2 minus square root of 49 minus 28 plus 15. And this is, looks like 49, negative 4 equals 2 minus square root of 49. 9 minus 28 is 36. And we add 15 to it. And 49 minus 28. Yes, 36. Square root of 36 is 6. And it looks like we get the same thing as before. Negative 4 equals negative 4. And that's a true statement. So it looks like our answers are negative 3 and 7. Okay. So next we're going to talk about this challenge problem. And this is just about extraneous solutions. I thought this next problem was pretty tough. Let's talk about what extraneous solutions are, sort of as a recap, and look at a very short proof on extraneous solutions. So an extraneous solution happens when we solve the problem and we don't even get a solution. So we get a solution, but it doesn't make sense. When we plug it back in, it doesn't make a true statement. So when you raise both sides of an equation to an even power, you have to check for extraneous solutions because raising both sides of an even power is not a reversible operation. So let me show you what I mean by that. Let me just not even look at this example problem yet. So if here's an example, if A equals B, then we can say A squared equals B squared because we're able to square A, and that means if we do a squared here, we do a squared there. So if A equals B, then A squared equals B squared. But we can't go the other way and say that it's necessarily A equals B. And let me show you why. If we have A squared equals B squared, and if we do the square root of that on both sides, when we do the square root, it's a square root is a plus or minus of the value. So one of our solutions, option one, is that we get A equals B. So that could be true that A equals B. It could be, but it isn't necessarily true. Option two is that we get negative A equals negative B, which is basically the same thing as option one, because if we did times negative one on both sides, we get A equals B. I'm going to put these options over here to the side, actually. Just get that out of the way. Okay, option three. Option three is we get a minus on one of them and not a minus on the other one. So option three is A equals negative B. And option four, you might have guessed it already, is negative A equals positive B. So because we have these different options of what it could be, it's not necessarily that this A squared equals B squared is equal to A equals B. So it doesn't go this way. It doesn't count that way. It's not a reversible operation. Okay, so this next question is asking us to figure out what this value is for D, that when we plug in x equals -1 gives us an extraneous solution. So it says which value for D makes x equals -1 an extraneous solution. So basically what we're going to do is we're going to set up the equation so that the original equation is option one that they give us. It's a true statement. And then our new equation, we're going to finish our new equation to find what the extraneous solution is. We're going to switch it around so that it matches option three or option four. I'll show you how to do that in just a second here. So it's telling us some information. It says x is -1, and it's saying what's D have to be so that it gives us an extraneous solution for this problem. So let's plug in x equals -1 first, and we'll figure out what D would be if it did not give us an extraneous solution. So we'll figure out what D is just regularly when it makes a true statement of when x equals -1. So let's plug in -1 for x. So we get 8 minus -1, the square root of 8 minus -1 equals 2 times -1 plus D. We get the square root of 9 is equal to -2 plus D. 3 equals -2 plus D. Plus 2 plus 2, and D equals 5. So far, if D equals 5, x equals -1 is not an extraneous solution. We want to figure out what it would be if it is an extraneous solution. So here's what we're going to do. We are going to take this equation, A equals B, and we're going to set it up so it makes it an extraneous solution. We're going to set it up so that it's actually A equals -B. I think that was option 3. Yeah. So we're going to rewrite this like this. We're going to say the square root of 8 minus x is equal to negative 1, or just negative quantity 2x plus d. That's negative 1 times all that. We're going to distribute the negative. Like that. And now we're going to plug in negative 1 again for x. Because it says when we plug in negative 1 for x, what's d have to be to give us an extraneous solution? We've written this equation so that it will give us an extraneous solution now because we've written it as a equals negative b. We put that negative in front there. So we're going to plug in negative 1 for x. And then minus d. And give the square root of 9 again equals 2 minus d. 3 equals 2 minus d. Minus 2 minus 2. And we get 1 equals negative d, or d equals negative 1. So when d equals negative 1, we get an extraneous solution for the equation. Okay. There is a way that we could show that this is an extraneous solution. So if we go back and plug all this information back in for d, if we put d equals negative 1 in, we should get answers for x. And if we plug those answers in for x, we'll get extraneous. We'll get at least one extraneous solution. Okay. So this is kind of a challenge problem for the extraneous solutions, but it is on Unit 10 for Quiz 1. And that is everything for Unit 10, Quiz 1.